Hello everyone, this is the week 2 addition within 100 solution video. Problem 1, compute the following. So let's start with the first equation. Let's start with 12 plus 36 and rewrite this in ladder method. So we always start on the right side. 2 plus 6 obviously is 8 and 1 plus 3 is 4. So therefore that gives us 48. Next, 45 plus 62. And as we said, we start on the right side. So 5 plus 2, that just gives us 7. And 4 plus 6, that gives us 10. So therefore, 45 plus 62 is 107. Next question, 36 plus 45. Well, this time we see that 6 plus 5 is equal to 11. But since there's 11 and we can't write two digits at the bottom at the same time, so we just carry over 1 over here. So that's just like equivalent to like adding another 1. So 1 plus 3, that gives us 4. And 4 plus 4, that gives us 8. So therefore, 36 plus 45 is equivalent to 81. 28 plus 40 is the next question. And 8 plus 0 is, of course, 8. And 2 plus 4 is 6. So this gives us 68. Next question, 51 plus 49. Well, we see here that 1 plus 9 equals to 10. So we write the 0 here and carry the 1 over to here. And we know that 1 plus 5 is equal to 6. So 6 plus 4 is equal to 10. So 51 plus 49 is equal to 100. And finally, 35 plus 47. And this time we see that 5 plus 7 is equal to 12. So we carry over the 1 here. And 1 plus 3 equals to 4. And 4 plus 4 equals to 8. So again, this is 82. And that's problem 1. Problem 2. David was driving from home to San Francisco. After he had driven for 36 miles, GPS showed that there were still 57 miles left. What was the total travel distance in miles? Let's see here. So this is San Francisco. So we write this, and this on the side is his home. So we write home. So after he had driven from 36 miles, so let's see here. This is equivalent to 36 miles. And the GPS showed that there were still 57 miles in the red. If we add these two together, then that is just the distance of the route. So we add 36 miles to 57. And 6 plus 7 is 13. So we carry over the 1 here. And then 1 plus 3 equals to 4. And then 4 plus 5 is equal to 9. So in total, what was the total travel distance? 93 miles. Problem 3. There were 4 teachers and 15 students on the playground. Later, 23 more students came to the playground. Then a teacher led another 15 students to the playground. How many people were on the playground now? So in the start, we have 4 teachers and 15 students. And then later, 23 more students came to the playground. So let's add this to the equation, 15 plus 23, and that gives us 38, since 5 plus 3 on the right side is 8, and 1 plus 2 is equivalent to 3. So therefore, now there are 38 students. And then a teacher led another 15 students to the playground. So we see here that if another 15 students come, then it's just 38 plus 15, and that gives us 53, since 8 plus 5 is equal to 13. So we carry the 1 over here. And 1 plus 3 equals to 4. 4 plus 1 equals to 5. So now there are 53 students. But there's one part of this question that you shouldn't miss. It says then a teacher led another 15 students to the playground. So this means that we should add another teacher to the 4 teachers already here. So that gives us 5 teachers. And then it asks us how many people were on the playground now. So 53 students plus 5 teachers, that just gives us 58 people. So 58 is your answer. Problem 4. Let's try to fill in the missing boxes. Number 1, 20 something plus 53 is equal to something 5. So we see here that the only solution is 2, because like in order for it to carry over, it needs to be 15. But in order for it to be 15, it would need something plus 3 equals to 15, and that would be 12. But 12 is not a valid case here, so therefore it is 2. So therefore we write 2 here. And after we figure out 2, we just add 22 to 53, and that gives us 75. So we write 75 here. And this time, something 5 plus 46 is equal to 80 something. So let's start off on the right side this time. 55 plus 6 equals to 11, so we carry over the 1 here. And 1 plus 4, as we already know, is 5. So 5 plus 3 equals to 8. So therefore, 3 goes right here. Next question. 40 something plus something 9 is equal to 70. We know here from the top, the only case is 1, because 1 plus 9 equals to 10. And then in order for it to carry over to the next number, it should be 9 plus something equals to 20, but that isn't possible since that number has to be 11, and that is not a possible case here. So therefore, we write 1 here. Then 41 plus something 9, we write 0 here, carry over the 1, and it says that the answer is 7, so the only case here left would be 2, since 1 plus 4 is 5, and 5 plus 2 is 7, sorry. So we write 2 here. And finally, the next question, something 7 plus 40 something is equal to 111. So as we can see here, the only case here would be to write 4, since 7 plus 4 equals to 11. And then again, if it's 21, then that is not possible because that is too big. So therefore, we write 4 here. And we know to carry over the 1, so 1 plus 4 equals to 5, because 4 is on the bottom right here. And 5, and it says that on the bottom, it's 11. So 5 plus 6 equals to 11. So we know that the answer must be 6. And then here are the answers. So let me just erase all the marks that we don't need so you can better see the answers. And that is problem 4. Problem 5. A, B, and C, D are two-digit numbers. If A, B plus C, D is equivalent to 129, then what is A plus B plus C plus D? On the right side, we can see that B plus D needs to clearly equal to 9. Because if B plus D is equivalent to 19, then that is just too big, since the largest these numbers can get are 9 plus 9, and that would only give us 18. So this is invalid. So therefore, B plus D must only equal to 9. So, and then this gives us many possibilities. 8 plus 1, 7 plus 2, 6 plus 3, and 5 plus 4. And you can do any of these, and you will still get 9. Then we know that if B plus D is equal to 9, then A plus C must equal to 12, since it says here at the bottom. So A plus C equals to 12, and this can be 8 plus 4, 9 plus 3, and so on. And then if we get A plus C equals to 12, and B plus D equals to 9, then 9 plus 12 gives us 21, and that is the answer of this problem. Problem 6. Put 8 numbers 1 to 8 in the following 8 boxes so that the equality holds. Each number is used only once. There are more than one correct answer. Finding one is enough. So the right side of these two-digit numbers on the left side must be equivalent to the green boxes on the right side. So for example, we can just do 2 plus 3 and 1 plus 4, and these numbers give us 5. And then we can just plug the remaining numbers into the equation. For example, we can just do 7 plus 6, which gives us 13, and 8 and 5, which also gives us 13. So these numbers should just be like equivalent to each other. Let's see if this is correct. 72 plus 63, let's start on the right side first. That gives us 5. 7 plus 6, 13. And then let's move on to the right side. 81 plus 54, that gives us 5. And 8 plus 5 equals to 13. And as you can see, these two are equivalent. So for this equation, you just need to do that the two sets of numbers on each side. For example, let's write here in the yellow, these two correspond to the right side yellow. These two need to be the same sum, while in the right side of these two numbers need to be the same sum as the right side of these numbers, if that makes sense. Problem 7. So in a sequence of numbers, the first term is 3. Each new term is obtained by adding 5 to the previous term. The first 4 terms are 3, 8, 13, and 18. What are the next 3 terms in the sequence? So let's see here first. We have 3, 8, 13, and 18. And we get this by adding plus 5 every time, because 3 plus 5 equals to 8, 8 plus 5 equals to 13, and 13 plus 5 equals to 18. And we need to figure out the next 3 terms. So let's add 5 to 18. So 18 plus 5, 8 plus 5, 13, carry over the 1, and that gives us 23. So we put 23 in here. And then next, 23 plus 5, 5 plus 3 equals 8, and we carry down the 2, so 2, that gives us 28. And finally, 28 plus 5, 8 plus 5 equals to 13. Put 1 over here, 2 plus 1 equals to 3, so this gives us 33. So 23, 28, and 33 are the numbers. And finally, problem 8. The following graph shows the number of students who play various kinds of sports: the AFL, NRL, netball, soccer, tennis, and athletics. So AFL and the NRL are 2 kinds of football competitions in Australia. The question is, what are the total number of students who play these sports? Looking at the graph first, let's look at the students who play the sport of AFL. So we see here that it corresponds to the letter 6, which is right here. So we put 6 right here. And then on the top, we see the words NRL that is in the middle of 10 and 8. So this gives us 9. And then netball, it is directly matching to the number 12. So we write 12 here. Then soccer, it's right across from 4. So we write 4 here. For tennis, let's write it in blue. Tennis is straight across to 8. So we write 8 here. And finally, athletics in red, let's see, it is directly to 4. So 4 again. So let's add up these numbers now. 6 plus 9 first, that gives us 15. Then 15 plus 12, that gives us 27. Then 27 plus 4, that's really easy, 31. And then in green, let's 31 plus 8, that gives us 39. And finally, 39 plus the 4, because 4 is the last one, that gives us 43. So in total, 43 students play sports. And that is it.